Hello guys, welcome back, and in today's video we are going to learn about introduction to organic chemistry. So mind you that you will be seeing a lot of new things in this chapter, but which will be explained in later videos and later chapters as well. First of all, where can we find organic chemistry? So everything around us, or almost everything around us, is made up of organic chemistry. So in biology, we learn about proteins, DNA, or fat. Those are organic chemistry. Also, the plastic bags that we use, to the medicines that we consume, the clothes that we wear, and the paint dye, all are organic chemistry. And the most important of all, the fuel or the crude oil that we use, or the electricity that we use for everywhere else, is also involved with organic chemistry. So what is organic chemistry made of? It's actually made of what we call hydrocarbons. So we call those molecules hydrocarbons because they are molecules which contain hydrogen and carbon only. For example, there can be different types of hydrocarbons. The bond between the carbons will actually can actually be a single bond, double bond, or triple bond. So based on those, their names will be different, which you will learn in a little while. However, you should know that the carbon atoms and the hydrogen atoms can only be joined by single bonds only. So let me refresh you a bit on why carbon can have only 4 bonds around it, okay? It's actually because the atomic number of carbon is 6, so it's 2.4, okay? So carbon atoms will have 4 electrons in the outermost shell, and hydrogen has an electronic configuration of just 1, meaning that hydrogen will have 1 electron to share with carbon. So this can be represented as carbon having a single bond connection to hydrogen. So each bond here represents a covalent bond, which represents a shared pair of electrons. So there are many different formulas to represent organic compounds, as you can see on the screen right now, and I'll explain each of them. Okay, so first things first is empirical formula. It shows you the simplest whole number ratio of atoms, and molecular formula shows you the actual number of each type of atom present in a molecule. Okay, for example, let's take a look at this. Okay, for example, let's say ethane, right, which is the formula of C2H6. This is the molecular formula because it's not showing the simplest whole number ratio yet. It is actually showing the actual number, okay? So this is your keyword here, and for empirical formula, the simplest whole number ratio is your keyword, okay? So if you find the ratio here, this will be CH3. So your CH3 is actually the empirical formula, and your C2H6 is your molecular formula. So we can also see that the molecular formula is also a multiple of empirical formula. Why? Because if you multiply CH3 with 2, you are going to get C2H6. That's why they are always a multiple of each other. So, to write down the general formulas first, you need to know 2 vocabularies here, which is the homologous series and functional groups. So there will be the homologous series means that they are a series of compounds which have very similar chemical properties. Why? Because they have the same functional group. This will be explained to you later. And they shows a trend in physical properties, and one member is different from the other one by CH2. And the functional group means that it's an atom or group of atoms, which is actually going to determine the chemical properties of a compound. So what's important here now is you pause the video and try to learn this now. So the alkane homologous series have a general formula of CnH2n plus 2. The alkene will have a general formula of CnH2n, and alcohol will have a general formula of CnH2n plus 1 and OH. So notice here that your OH is your functional group. In later organic chemistry, you will be learning more functional groups. So I'll try to explain what this actually means, okay? So right now, what you need to learn again is the prefix, such as carbon 1 represents meat and carbon 2 represents eat, okay? So you need to know which prefix represents which carbon number atoms here first, okay? Okay, so let's write down methane for example. So methane, methane. Okay, so we know that since it ends with A and E, it's an alkane. So the formula that we should use is CnH2n plus 2. So since it's meth, meat, our prefix tells us that there's only one carbon. So we're going to replace 1 in N. So this will be C1, but since it's 1, we're not going to write it. And H2 into 1 plus 2. So we will get CH4. So let's try for one alkene, okay? So let's say propene. This will be PROPENE, propene. Since it ends with E and E, I know that my general formula is CnH2n. From here, since it is prop, I have 3 carbon atoms here. So C3H, this will be 2 multiplying with 3, so this will be C3H6. Now let's do one for alcohol. Alright, so let's try for one alcohol, which let's say bute. So the alcohol name would be butanol. So since it ends with OL, okay, I know that my general formula is CnH2n plus 1 OH, and since it is bute, I have 4 carbon atoms. So this will be C4H 2 into 4 plus 1 OH. This will be C4H 9 OH, and the name would be butanol. So the one that I have written, the homologous series that I have written down here is the alkane homologous series, which is methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Alright? So one member is different from the next by CH2, and they are all going to have the similar chemical properties because they are in the same homologous series, and their physical properties gradually increase or decrease. What I mean by that is that, for example, the melting or boiling point of CH4, if I say it is 10 degrees Celsius, this will eventually be 20, this will be 30, so it will be increasing gradually. And that is what I mean by the second sentence shows a trend gradation in physical properties. In exam, the characteristic features or the properties of homologous series is very commonly asked, and you need to be able to answer these 3 precisely. Now let's go to structural formula. Now a structural formula shows how the atoms in a molecule are joined together. So from the general formula, we can only know how many carbons and how many hydrogens are there, but we don't know how they are connected. For example, the general formula of butane is C4H10, and the display formula for it should be, you first draw 4 carbon atoms, 1, 2, 3, 4. And then you fill up the rest with hydrogen. Since you already have 1 bond, there should be 1, 2, 3. You already have 1 and 2, so 1, 2. You already have 1, 2, so 3, 4. You already have 1, so it's only 1, 2, and 3. And you fill those up with hydrogen. So this is your display formula because it is actually showing all the bonds and all the connections. Now, if we write this in structural formula or a condensed structural formula, this will look like this. CH3, which comes from this, and it will go to CH2. So it will be CH3, CH2, CH2, CH3. Notice here that your carbon will always form 4 bonds, and the hydrogen or halogen atoms will just form 1 bond, and the oxygen, which we will see later, will form 2 bonds.